well, the NAT. Okay, let me to configure the fast Ethernet 01 as the NAT inside interface. Fast Ethernet 01 IP NAT inside, so easy. After that, interface fast Ethernet 00 IP NAT outside. Okay, that's it. If you want, you can use show IP interface fast Ethernet 00. Here we can see that this interface is the NAT outside interface. Okay, you know that in this interface we have configured the IP NAT outside. Okay, look at here, network address translation is enabled, interface in domain outside, or show IP interface fast Ethernet 01. Again, network address translation is enabled, interface in domain inside. So easy. Okay, then we need to configure the translation table. Here we are using the static method, you know, and here I'm going to configure the translation table. IP NAT inside source, then static, first private IP, second the public IP, 192.168.100, okay, 110, to the public IP of 100.0.1, for example, the 100.0. 0. Look at here. Here we should use 100.0.0.3. Okay, 100.0.0.3. So easy. This is the first line. Again, IP NAT inside source static from 192.168.120, 100.0.0, for example, 4. Then IP NAT inside source static 192.168.130. Okay, 100.0.0.5. That's it. If you want, now you can check the show IP NAT translation table. It is so easy to verify the translation table. Inside local means the private IP address, inside global. That's it. Now we can try to send traffic from the computer to the server. First, I'm going to show you. After that, we can capture the packets. Ping 100.0.110 from the computer 1. As you can see, we have connectivity without any problem. Also from the computer 2. Okay, again we have connectivity, and finally in the computer 3, as you can see, we have connectivity. It is so easy. Okay, let me to show you the translation with capturing before and after the traffic is receiving in the router 1. Here you can use the capture, start capture, then start Wireshark. Okay, you know that the Wireshark is a software for sniffing the packets in one, for example, interface or in one link. This is the capture of the interface fast Ethernet 01. After that, let me to capture the outside interface. Okay, in the packet tracer you can use the simulation mode. Okay, this is the capture or a sniff of the outgoing interface. Now let me to send traffic again, for example, from computer 1, ping 100.0.110. Okay, now this is the capture before and after. Let me to show you. Stop these two captures. Look at here, the traffic received from the 192.168.110 to the 100.0.110. This is the ICMP, as you know. And as you can see, after the, for example, NAT, we have 100.0.0.3 to 100.0.110. As you can see, the source IP now is changing. After that, when we are receiving the ARP reply, source IP is 100.0.110, destination is 100.0.0.3. As you can see here, now the destination IP translated to the private IP address 192.168.110, and it is so obvious. The next command for verifying the function of the NAT is the show IP NAT statistics. Okay, show IP NAT translation is the one command, and show IP NAT, for example, statistics is the next command for verifying the function of the NAT. Total active translation now is 3. All of these 3 translations are static. We will learn about the dynamic in the next method, and after that here you can see outside interface means IP NAT outside the interface, and then this is the inside interface. Here we can see the number of packets that match with the for example, NAT rule, and also some other useful information that here we have. But about the static NAT, now we have one question, one important question, and that is Now we are using one public IP address, for example 100.0.0.3, for one private IP address. This means that for each private IP address now you need one public IP address, and this means that we don't reserve any, or we don't, for example, save any public IP address. For each IP private IP, we need one public IP. Okay, because of that, we can understand that the static NAT is not a suitable method for saving the public IP address. Actually, here now we can understand the concept of NAT, and after that we will be ready for learning the other methods of NAT that may be useful for the preventing the wasting of IP address. A static NAT has another function. Let me to talk about the real function of the static NAT. About the static NAT, now we can understand the concept and also the configuration, and it is useful for learning the other methods. This means that we are learning a static NAT in CCNA for becoming ready for learning about dynamic NAT and also dynamic NAT overload. But now I am going to give you to inform you about the real function of the static NAT. A static NAT is not using for the saving the public IP address. The function of a static NAT is publishing one server inside of our network for the outside. Assume that here we have one computer or one server, and we want to publish this server into the internet. For example, here we have a web server, and we are for example installing this web server inside of our company, and now we want to give access to this server to the outside of company, for example to the internet. Okay, you know that from the outside nobody can connect to the for example 192.168.110 because this is private. But now from the outside, if we are receiving a traffic for 100.0.0.3, okay, actually the router one should translate the destination IP to the 192.168.110. I will show you. Actually, for example, in the public DNS servers, here we have www.example.com. Okay, in the public DNS servers, we are creating one record in DNS with the IP of 100.0.0.03. okay, 100.0.0.3. okay, this is now the record of the DNS server. And if a system from outside of the network needs to connect to www.example.com, you know that it should first send a DNS query, okay, to the public DNS servers, and after that it will receive the IP address of the 100.0.0.3. You know that this is not the real IP address of the for example server of the www.example.com. but now when the server trying to connect to 100.0.0.3, it should send a traffic to the destination of the 100.0.0.3. Because of that, this traffic, when receiving in the router tree, should match it with this, for example, translation table and this record, and it should, for example, translate the destination IP to the 192.168.110, and also when the answer or the reply from the server, the C1, is receiving here, now the source IP is the 192.168.110, the router one should translate the source IP to the public IP address. Actually, we can say that in normal scenarios, okay, in the previous scenario, first we experience one traffic from the inside going to the outside, and because of that, first we translated the source IP, and in the receive we translated the destination IP. But now here the first traffic is receiving from the outside, and the answer is receiving from the inside, the reverse direction. But again, we are changing when the source IP, when the traffic is going from the inside to the outside, and we are translating the destination IP when the traffic is receiving from on the NAT outside interface. Here in the command you can understand easily why we should do this function. IPNAT inside source means if a traffic from the inside wants to send to the outside, okay, from the inside you should change the source, and this is the static translation table. Very good. In the Next method, we should talk about the dynamic NAT and also dynamic NAT overload or path, but I'm not going to talk about them in this video because first you should implement the static NAT, and after learning the static NAT, you will be ready for